Okay, so in this question here, we're asked to sketch a velocity time graph, and you can see I've already got my axes drawn, right? With O there, and of course you've got your axes labelled, velocity, with the units, and time there with the correct units as well. And we're interested in the journey of this vehicle between A and B. When it passes through A, it's got a speed of 20 meters per second. So we'll label that there 20, and we're told that it keeps going at this speed, okay? The constant speed, it keeps up 20 meters per second for 8 seconds, okay? So in order to sort of identify that on here, we need to have a flat line, yeah? Okay, for 8 seconds. So that will do there. That's showing, you know, with a flat line, we're showing that the speed is remaining the same, isn't it? The speed is always 20 for a period of 8 seconds. Okay, so what I'll do as well, I'll put draw a broken line down here to show that takes us to 8 seconds. All right. Also, remember with a flat line, it's also telling us that the acceleration is 0. Yeah, there's no acceleration because, of course, the acceleration is the gradient value, and the gradient is 0. Yeah, on a flat line. Okay, so acceleration is going to be 0, isn't it? If it keeps going at the same speed of 20. Then, though, it says that it slows down, right? For 10 seconds until it reaches a speed of 6. So when I put 6 along here, right, we try and get this roughly right, even though it's a sketch. 10 is going to be sort of in the middle, so 6 would be about there, wouldn't it? Okay, so 6 slows down to that speed of 6, okay, over a period of 10 seconds. So from 8 there, another 10 seconds will take us to 18, which is about there, I'd say. Okay, so what I'll do is, I try and find that point here, right? I'll draw the broken lines to show the actual time of 18 seconds and the speed of 6 meters per second. And we need to show then on our velocity time graph that the speed is reducing from 20 to 6. And then once we're from there, then it says it maintains this speed. It maintains this speed until we get to time equals 40 seconds. So time equals 40 seconds. Well, that's 18, so 40 is going to be about there roughly, isn't it? Okay. So it maintains this speed. In other words, it keeps going at 6 meters per second. So we need another flat line, okay, to show that it's not accelerating, it's not decelerating, it's going at a constant speed. So we have a flat line, gradient is 0, acceleration is 0, and it stays at 6 meters per second until time is 40. And when time is 40, it passes through B, okay? And then that's it then. We don't pick up any more information. That's the end of the story. Okay, we're only interested in what happens between A and B. And there's our velocity time graph. Okay, so with part B then, we're asked to work out the magnitude of deceleration. And remember, with deceleration, okay, or acceleration, it's all about working out the gradient. Okay, so the gradient is the rise divided by the step, isn't it? Okay, rise divided by step, which we learnt in GCSE. But the rise in this case, okay, in this time interval, will be, of course, that vertical change in velocity there, and the step will be the time, won't it, over the time period. Now, the change in velocity, right, it actually reduces the velocity, doesn't it? Okay, so we actually lose velocity. Okay, so it goes from 20 to 6. So actually, it's going to be negative, isn't it? Okay, it's going to be negative 14. You lose the speed of 14 meters per second. And to show that in my workings, I just put my final velocity there, which is 6, take away my initial velocity, which is 20, and you'd get minus 14, wouldn't you? It shows that you've lost 14 meters per second there in speed. Divide them by the time, which is, of course, 10 seconds there, from 8 to 18, and that works out to be minus 1.4 meters per second squared. Okay, so that's showing the acceleration, and of course it's negative, which means then we've got deceleration. So remember that, right? Negative acceleration means that actually we've got deceleration. Yeah, it's slowing down. Okay. Okay, so whenever you get a negative answer out, we call it deceleration instead. All right, and you should know that anyway, because you can see, like it says in the question, isn't it? But you can see it's sloping downwards. Okay, so it's a negative gradient. Most important though, when in part B, it's asking for the magnitude. Okay, so when asked for the magnitude of the deceleration, we always write it as a positive answer, right? Because magnitude means size, right? we want the size of it. So when we consider the size of something, we always put positive answer down. All right, it's really important. Okay, when you consider the size of it, always write the positive of it down. Part C then, okay, we want the distance AB, right? So when you work out the distance AB, the distance, of course, is the area under the curve, okay? Okay, or the graph, the area here, right? So if we work out the area, and then what I'm going to do is I'm going to split this shape up into three parts, maybe A, B, C, okay? And the area of A, I can work out quite simple, it's a rectangle, okay? So 8 there, isn't it? And it's 20 high, so 8 across, 20 high, so length times width, 20 times 8, which is 160 meters. Part B then, area B, you should notice B is a trapezium, right? Okay, I mean, you could split this up further, couldn't you? You could think of that as a rectangle and a triangle. But better, if we turn it round, look, you can see it's a trapezium. Ignore that line there, okay? Trapezium with those two sides parallel, okay? So all you need with the trapezium is that side and that side added together. So that length there is 6, isn't it? That's 20. So you're going to need to add this side to this side, okay? And remember the formula is half A plus B times H. So it'll be half. So this side here will be 20, and then the other side then will be 6. And then of course you times it then by the height between them. Now the height between them is this distance here, which is 10. So if you work that out, okay, you can use your calculator. So you get, what do we get there? So 0.5, 26 in there, times 10, and we get 130 meters. And then area C, look at C, it's just another rectangle, isn't it? So that length time interval there is 22, that width there is 6, so 22 times 6, okay, is a 132 meters, okay? And then all you've got to do then to get total distance, you need to add them up. 160 plus 130 plus 132, okay? And we get a final answer 422 meters.